consistently across the internet from router to router. Tim Berners-Lee designed this. And when they arrive at the destination, they are reassembled. Not all the frames follow the same path. The routers help the frames get to where they need to be, but not all of the frames are likely to follow the same path. But hopefully all of them arrive at the destination. In reality, some of them may not. They may be lost or damaged along the way. A frame, and by the way, I'm teaching this from a managerial perspective and not from a technical perspective. And the explanations I'm giving may not be satisfactory at a technical level, but it's adequate for a managerial understanding of how networks work. The parts of a frame include the header, the payload, and the trailer. So a frame is a unit of data that moves across a network as a unit. And it's kind of like a letter going through the postal service. It has a header, which is kind of like the envelope on which an address is written. It has a payload, which is like the paper inside the envelope, which contains the information that this particular frame is carrying. And then a frame also has what is called a trailer, which does not have a postal analogy, I think. The trailer of a frame moving across a network or the internet keeps some information about where it's been, the routers that it has visited along its path across the internet. When a frame arrives at a router on the internet, the router looks into the header of the frame to see where it needs to be. The router is not likely to be directly connected to the destination, but somehow the router knows how to get that particular frame closer to where it needs to be. And so it sends the frame to another router that it knows about. And the router then hops the frame then hops from router to router to router until hopefully it arrives at its destination. When a router receives a frame and sends it along to another router, it writes some notation into the trailer of the frame about where it's been, where the frame has been, and how long it took to be serviced along the way. The frame has a hop limit, which means that after it hops about 30 times or so, if it's not where it needs to be, it self-destructs. Were it not for this hop limit and this behavior, frames that get lost would just possibly bounce around on the internet forever, and we don't want an internet full of lost frames. So there's kind of a safeguard here built in to prevent frames that for whatever reason are not going to reach their destination from clogging up the internet by just hopping around almost indefinitely. Now, on the internet, there are protocols. A protocol generally means an agreed-upon way of doing things. And there's different protocols, IP, internet protocols, for different kinds of data transmission. There's a protocol for email, there's a protocol for video, and so forth. And some of the protocols are said to be frivolous, and other protocols not frivolous. Think of a person who is described as frivolous. Frivolous means having a kind of whatever attitude, kind of not caring, not being too serious about things. If a protocol is frivolous, what that means is that if some of the frames do not arrive at the destination, the protocol just says, let's not worry about it. They didn't all get there. But other protocols are not frivolous. And in this case, if some of the frames don't make it to the destination, then the destination machine sends a message back to the origin machine saying, I didn't get it all. Please resend particular frames across the internet. So a frivolous protocol just doesn't worry about lost frames. A serious, non-frivolous protocol gets them all, even if it has to go back across the internet one or more times to get all of them. If you're, for example, watching a video that's streaming across the internet and a few frames get lost, you'll never see the difference. And there's no reason to go back and get them. But when you get email, you expect it to all be there. So one protocol is frivolous and the other is not frivolous, and for good reason. So why should managers care about such things? Well, modern organizations depend upon computers, networks, and the internet as essential infrastructure for what the organization does. Managers should remain aware of the fact that these communication systems that we take for granted and just expect to work every time as if they were, hardwired, are really incredibly complex. And, when something fails, perhaps we should marvel that it works as well as it does. We depend upon these systems. They are complex. And we should realize that there is complexity here, and therefore there is a degree of risk. Networks are designed to be highly reliable, dependable, and to have the bandwidth that we need to do what we need to do.